So good morning everyone. So today we'll discuss about the working of an encoder. So in the last class we have discussed about the working of a decoder. A decoder is a logic circuit that receives the codes. Some kind of codes is received at the input signal, and depending upon the code received at the input, it is converted into some other useful formats. Now here this is a decoder. So in a decoder, actually the converting some familiar symbols or numbers into some code, we are going to convert it into some code format. That is what is called as a uh, encoding. So here this is just the opposite process of that of the decoder. An encoder will be accepting one of the inputs, which can represent a digit, it can represent a octal digit, it can represent a decimal digit, and convert it into some coded forms. And the coded forms can be either binary number codes or it can be BCD codes, etc. Now let us discuss about the working of an octal to binary encoder. So in an octal to binary encoder, you will have a how many inputs? Octal, 8 inputs will be there. 8 inputs will be there, and 3 outputs will be there. So 3 outputs. Now the labeling the inputs, it can be I0, I1, I2 up to I7, or it can be D0, D1, D2, D3 up to D7. And output is Y0, Y1, Y2, 3 outputs. So you can use any representations for marking the inputs and outputs. Now let us say that in this 8 inputs, if my D0 receives a signal there and all others are not receiving any signals, so that is why I am writing it by 1 at D0, and all other inputs are set to 0. So that means D0 is only receiving the input and all other input signals are not receiving any signals. So in that case, I am going to generate it as a code, and that code is corresponding to 0, that is 0 0 0. Then if my D1 receives any input, D1, so corresponding to decimal 1, I should code it into 0 0 1. Now for D2, I should code to 2, decimal 2, that is 0 1 0. If D3 receives an input, that is D3 becoming 1, the corresponding code should be that of decimal 3, that is 0 1 1. Then if D4 is receiving any input codes corresponding to the decimal 4, I should produce a code, that is 100 is the code. Then if D5 is receiving, the output should be 101. Similarly, if D6 is high and all others are 0, then the code should be that of a decimal 6, that is 110. Now if D7 is 1, the corresponding output should be code should be that of a decimal 7, that is 111. So by completing the truth table, I can write like this. Then I will define the output y2, y1 and y0 separately and implement it using the logic diagram. So corresponding to the y2 case, if you take y2, when is your y2 going to be high? You check the condition when y2 going to be high. Y2 can be high when you look at the last 4 columns. I can see that y2 is high in that case. So y2 is high when my d4 is high, then d5 is high, then d6 is high, then d7 is also high. So under these 4 conditions, my y2 is going to be high. So y2 is high when d4 or d5 or d6 or d7 is high. Similarly, I can develop the expression for y1. Y1 is high when these 2 conditions, right? That is d2 is high or d3 is high. Or see these conditions also, you can see y1 is high. So when you say y1 going to be high in this case, y1 is going to be high when d6 is high and d7 is also high. So I can write y1 is high when d2 is high or D3 is high, or D6 is high, or D7 is high. Similarly, when is your Y0 going to be high? Y0 is going to be high here, 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 and here. So Y0 is going to be high when D1 is high, D3 is high, D5 is high, and D7 is high. Okay, so this is the expression. So Y2 is 1 when D4 or D5 or D6 or D7 is high. So you just draw the input lines first. D0, D1, D2, D3, D4, D5, D6, D7. I can draw the input lines. Then after drawing the input lines, you take your expression for Y2. So what is your Y2 now? So Y2 is high when D4, D5, D6 or D7 is high. So you take the inputs from D4, D5, D6 and D7 and give it to an OR gate. So this output corresponds to Y2. Similarly, your Y1. When is your Y1 high? D2 or D3 or D6 or D7 is high. So take D2, take D3, then D6 and D7, connect it to an OR gate, and the output of this OR gate is Y1, and here it is written as B, don't mind it. Then Y0 is high under what condition? When D1, so take it from D1 or D3 or D5 or D7. So take all the inputs from D1, D3, D5 and D7 and connect it to an OR gate. So the output of this OR gate will be Y0. So this is the octal to binary encoder. Now next you will discuss about the decimal to BCD encoder. So decimal. So how many inputs will be there for this encoder? You are going to receive 10 inputs and it is converted into some other codes, and that code should be BCD, binary coded decimal. So the output should be 4 output lines should be there. So 10 input lines from D0 to D9 and 4 output lines from Y0, Y1, Y2 and Y3, 4 output lines. So when you are coding a particular decimal, ഇപ്പോൾ 10 ഡെസിമൽ നമ്പർ ഉണ്ടെങ്കിൽ അതിനെ കോഡ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമുക്ക് 3 ബിറ്റ് യൂസ് ചെയ്യാൻ പറ്റില്ല. വി ഹാവ് ടു യൂസ് 4 ബിറ്റ്സ്. അപ്പോൾ അതുകൊണ്ടാണ് 10 ഇൻപുട്ടിനെ നമ്മൾ എടുക്കുന്നു, എന്നിട്ട് അതിനെ നമ്മൾ 4 ബിറ്റുള്ള കോഡ് ഫോമിലേക്ക് മാറ്റുന്നു. 3 നമുക്ക് പറ്റില്ലല്ലോ, കാരണം 10 സിമ്പിൾസ് 10 നമ്പേഴ്സ് ഉണ്ട് ശരിക്കും. ആ 10 നമ്പേഴ്സിനെ നമുക്ക് കോഡ് ചെയ്യണമെങ്കിൽ നമുക്കതിനെ ഒരു 4 ബിറ്റുള്ള സിസ്റ്റത്തിലേക്ക് മാറ്റാനേ പറ്റുള്ളൂ. 3 ബിറ്റുള്ള സിസ്റ്റം കൊണ്ട് 000 അങ്ങനെ 111, അതായത് 0 to 7 വരെ 8 എണ്ണേ പറ്റുള്ളൂ. നമുക്കിവിടെ 10 ഇൻപുട്സ് ഉണ്ട് ഡെസിമൽ എന്ന് പറയുമ്പോൾ. അപ്പോൾ അതിനെ കോഡ് ചെയ്യണമെങ്കിൽ നമുക്കൊരു മിനിമം ഒരു 4 ബിറ്റെങ്കിലും വേണം. അപ്പോൾ അതുകൊണ്ടാണ് നമ്മൾ Y0, Y1, Y2, Y3 എന്നുള്ള 4 ഔട്ട്പുട്ട്സ് ആയിട്ട് നമ്മൾ കൺസിഡർ ചെയ്തത്. അപ്പോൾ ഇൻപുട്ട് 10 കാണും, അതിൻ്റെ കറസ്പോണ്ടിങ് ആയിട്ട് 4 ഔട്ട്പുട്ട് ലൈൻസും ഉണ്ടാവും. അപ്പോൾ ഇൻ ദിസ് കേസ് when D0 is high, അതിൻ്റെ കറസ്പോണ്ടിങ് കോഡ് എന്ന് പറയുന്നത് 000 ആയിരിക്കും. D1 when it is high, the corresponding code will be 001. D2 high ആകുമ്പോൾ 2 എന്നുള്ള ഡെസിമലിൻ്റെ കറസ്പോണ്ടിങ് കോഡാണ്, സോ 0010 ആയിരിക്കും അതിൻ്റെ ഔട്ട്പുട്ട്. when D3 is high, the corresponding code will be 0011. D4 ഹൈ ആകുമ്പോൾ ദ കറസ്പോണ്ടിങ് കോഡ് എന്ന് പറയുന്നത് കറസ്പോണ്ടിങ് ടു ഡെസിമൽ 4 ആയിരിക്കും, ദാറ്റ് ഈസ് 0100. D5 ഹൈ ആകുമ്പോൾ ദ കറസ്പോണ്ടിങ് കോഡ് വിൽ ബി 5ന് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള കോഡ്, ദാറ്റ് ഈസ് 0101. അപ്പോൾ ലൈക്ക്വൈസ് യു ക്യാൻ കംപ്ലീറ്റ്. വെൻ D9 is high, D9 ഹൈ ആകുമ്പോൾ D9 ഹൈ ആയിട്ട് ബാക്കി എല്ലാം 0 ആണ്. D9 ഹൈ ആകുമ്പോൾ യു ക്യാൻ സി 9ന് കറസ്പോണ്ടിങ് കോഡ്, അതായത് 1001 ആയിരിക്കും. അപ്പോൾ 10 ഇൻപുട്ട് ലൈൻസും ഇപ്പോൾ ഓരോ കേസിലെയും ഇൻസിഡൻ്റ് ആവുന്നതനുസരിച്ച് ഒരു കോഡ് നമ്മൾ ഡെവലപ്പ് ചെയ്തു. അപ്പോൾ അതിൻ്റെ ഔട്ട്പുട്ടും നമ്മൾ എഴുതി Y0, Y1, Y2, Y3. നൗ യു ചെക്ക് ഈച്ച് ഔട്ട്പുട്ട്സ് Y3, Y2, Y1 and Y0 and see under which situations Y3, Y2, Y1 and Y0 is going to be high. So if you check Y3 ഇപ്പോൾ ഹൈ ആവും. Y3 ഹൈ ആവുന്നത് ഈ കേസിലും ഈ കേസിലും ഈ കേസിലുമാണ്. ആ രണ്ട് കേസിലും that means D8 should be high and D9 should be high. You check. So D8 and D9. Okay, so Y3 is high when D8 or D9 is high. Similarly, when Y2 is going to be high, Y2 is going to be high under which situation? Y2 is going to be high when this condition, or this condition, or this condition, or this condition. 4 conditions. That means Y2 is going to be high when D4 is high, D5 is high, D6 is high, or D7 is high. Okay. So I can write like this: Y2 is high when D4 or D5 or D6 or D7 is high. Then when you say Y1 going to be high, check the truth table. Y1 is going to be high when D2 is high, D3 is high, D6 is high, or D7 is high. So under any of these situations, Y1 will be high. Similarly, Y0 will be high when D1 is high, or D3 is high, or D5 is high, or D7 is high, or D9 is high. So this is the case. So based on that, you can draw all the input lines first: D0, D1, D2, D3, D4, D5, D6, D7, D8. So you can unnecessarily not take like this. You can draw in any way. You can start from D0 from here, D0, D1, D2, D3, anyway you can draw. Just draw all the input lines. Then what is your Y3? Y3 is one when D8 or D9 is high. So take the inputs from D8 and D9, give it to an OR gate, then you will get Y3. Similarly, what is your Y2? Y2 will be high when D4 or D5 or D6 or D7. So take it from D4, D5, D6 and D7, connect it to an OR gate. Then similarly, Y1 also you can take correspondingly, Y0 also you can take correspondingly. So this is the implementation diagram for a decimal to BCD encoder. So this is all about the encoder sections. Hope you have understood the difference between a decoder and an encoder. Decoder, it is a logic circuit that receives a code and convert it into uncoded form, some number systems. Whereas in an encoder, it receives certain inputs. It can be representing a digit like a decimal or an octal digit, and converts into some coded form. So this is the basic difference. So hope the session is clear to you. Please go through the notes sent, and then if you have any doubts, you can contact me personally to clarify your doubts. Thank you.